What's up, everyone? In this video I'll be going over Leetcode problem 1. At least from today's date, it's problem 1. Might change later. This problem is called Two Sum and is ranked as an easy problem. So let's go ahead and read the problem description. Given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. And you may assume that each input would have exactly one solution, and you may not use the same element twice. That's perfect. And you can return the answer in any order. Now, we can look at take a look at an example of an input and an output and see how that works. So we're given a target number, and we're trying to find that in the array. We're trying to find a pair of numbers that add up to that target. So in this case, 2 and 7, they add up to 9. So we return 0 and 1, or 1 and 0, because they said order doesn't matter. So you can return either one. In this example, target is 6, and we can see that 2 and 4 add up to 6, so we can return 1 and 2, because we start at 0, 0, 1, 2, so 1 and 2 are 2 and 1, both work. In this case, target is 6, and we only have 2 elements, so it's going to be 0 and 1. Now, for this problem, one obvious solution would be using a nested for loop, in which we pick an element in the array and we go through each one after it to see if their sum add up to that target. But this would have a time complexity of O of n squared, which in this case is not the optimal solution because we go through all the numbers twice when we know there could only be one solution. So there's really no point of doing that. So another solution for this would be to use a hash map or a dictionary in Python. So a hash map if you're using a different language like Java or something else, but in Python you can just use a dictionary. Now, why would you even do that? Well, we know that a hash map or a dictionary, they have a constant lookup time, so of 1. So, and the way this could help us is by looking up a specific complement for the number that we're currently on. And let me explain that. So we know that we are required to return indices of two numbers. And these two numbers add up to the target. So we can call the two numbers x1 and x2, right? So we know that x1 plus x2 equals the target. And so what we can do is that when we visit each number, let's call that number x1. So let's say we're at x1 now. We check if we already visited target minus x1, which what this is just x2. So if we already visited a number that is equal to target minus x1, then we already visited x2, so we already have the two numbers. And then we can return the indices. And the way we return the indices is that because in the case that we didn't visit already, we store in the dictionary or the hash map the number as the key and the index of it as its value. So if we visited that already, we just go look up the key and we get the value, which is the index of that number, and we return that. Now this would have a time complexity of O of n, because we only go once through the array. We only visit each element only once. But it would also have a space complexity of O of n, because we might have to store each element. So if we're storing each element in the array, then the space complexity is O of n, because the dictionary, we're storing everything in the dictionary. So let's check out the code and go through it and see how it works. So the first thing we can do is we make a dictionary. We can call it anything. So let's say let's call it df. This is how we make a dictionary. Then we can start a for loop. Now I use enumerate because each number I go to, I want the index and the number, and this is just an easy way of doing that. I'm using Python here, and first thing we do is we check if target minus n, right, is in the dictionary. If that's the case, then we're done. So we just return df at target minus n. So basically that's the other number, the index of the other number right here, and the index of the number that we're currently on. Now, otherwise, we just store the number. We just store the index of the number, so not the actual number. So this is going to be our key, and this is the value. So this is the index we're on. This is the number we're on. And that's it. This is O of n, and that's the whole solution. So let's actually run it. Submit. Great, it works. I hope this video helped you, and see you in the next video.